Hello, science fans. Let's talk about something we all feel: heat. When the sun beats down on a summer day, what do? You might head for the shade, grab a cold drink, or stand in front of a fan. We humans are pretty clever when it comes to finding ways to cool off. But what about our buildings? Our homes, our schools, our offices? They get hot too. As our world gets warmer, keeping these big structures comfortable is becoming a huge challenge. Think about it. Cities are full of buildings that soak up the sun's energy all day long, making everything even hotter. Currently, our go-to solution for a hot building is the air conditioner. And don't get me wrong, air conditioning is a remarkable invention. It can turn a sweltering room into a cool oasis. But running all those AC units uses an incredible amount of electricity. This energy often comes from burning fossil fuels, which releases greenhouse gases into the atmosphere. So in our effort to cool our indoor spaces, we are actually contributing to the long-term warming of our entire planet. It's a tricky cycle, and it's one we need to break. We need a smarter way, a more efficient way, a more natural way to cool down. This is where science gets really exciting. Instead of just using more power, what if we could learn from the world around us? Nature has been solving problems like this for billions of years. Organisms have developed amazing strategies to survive in all sorts of environments, from the coldest Arctic regions to the hottest deserts. By looking closely at how life has adapted, we can find inspiration for our own engineering challenges. This approach is called biomimicry, imitating nature to solve human problems. And one of the most effective cooling systems ever designed is one you carry with you every single day. So consider this. What if our buildings could cool themselves off in the same way our bodies do? What if, when a building got too hot, it could just sweat? It sounds like something out of a science fiction movie, doesn't it? But it's an idea that engineers and scientists are taking very seriously. Imagine a skyscraper or a house that can actively release heat without using massive amounts of electricity. This isn't just a cool idea, pun intended. It's a revolutionary concept that could change how we design our cities and manage our energy, leading us toward a more sustainable future. To understand how a building could sweat, we first need to understand how we sweat. Your body is an amazing machine, and it has a built-in cooling system that is both simple and brilliant. When you get hot from running around, playing sports, or just being out on a warm day, your internal temperature starts to rise. Your brain, acting as a thermostat, senses this change and sends a signal to millions of tiny sweat glands located all over your skin. These glands then get to work, releasing a liquid, sweat, onto the surface of your skin. It's a beautifully simple process. Now, the real magic isn't in the sweat itself, but in what happens next. This is all about a fundamental principle of physics: evaporation. For a liquid to turn into a gas or vapor, it needs energy. When the sweat sits on your skin, it absorbs energy from its surroundings. What is the biggest source of energy right there? Your own body heat. As the water in your sweat evaporates and turns into water vapor, it takes that heat energy with it, carrying it away from your skin and into the air. This process is called evaporative cooling. This is why you feel a cool sensation after you've been sweating, especially if there's a breeze. The moving air helps the sweat evaporate even faster, which pulls more heat away from your body more quickly. It's an incredibly efficient way to lower your surface temperature and keep your internal organs from overheating. Without this ability, humans wouldn't be able to live in many of the hot climates we inhabit today. It's a survival mechanism that has been perfected over millions of years of evolution, a masterpiece of natural engineering that works without any plugs or batteries. So, to recap the science, your body gets hot, your brain sends a signal, your glands release sweat, and the evaporation of that sweat pulls heat away from you. It's a constant self-regulating cycle that keeps your body in balance. This elegant, low-energy solution from nature is exactly the kind of inspiration we need. If we can figure out how to apply this same principle, using the power of evaporating water to remove heat, to the materials we use to build our houses and offices, we could unlock a whole new way of thinking about architecture and energy. Now, let's take this brilliant idea from biology and apply it to architecture. How can we make a building sweat? Scientists and engineers are developing innovative materials and systems that can do just that. One of the most promising ideas involves creating a building skin, or facade, that can hold and release water. Imagine a wall made of a special porous material, almost like a ceramic sponge. This material would be connected to a water supply, like a rainwater collection tank on the roof, allowing it to absorb and store water within its structure. It's like giving the building its own set of sweat glands. When the sun beats down and the building's outer surface heats up, sensors would detect the temperature rise. These sensors would act like the building's brain, signaling that it's time to cool down. In response, the system would allow water to seep through the porous outer layer, dampening the surface. Just like sweat on your skin, this thin layer of water would then begin to evaporate. As it turns from a liquid to a gas, it would pull a significant amount of heat energy away from the building's wall, preventing that heat from ever getting inside. The result is a cooler interior without the constant hum of an air conditioner. This system is far more efficient than traditional air conditioning. An AC unit works by using a lot of energy to pump heat from inside a building to the outside, often just moving the problem around and making the city hotter. A sweating building, however, uses the natural passive process of evaporation. The only energy it really needs is a small amount to run the water pumps and sensors, which is a tiny fraction of what a conventional cooling system demands. This means a drastic reduction in electricity consumption and, consequently, a much smaller carbon footprint for the building. There are different ways to achieve this effect. Some designs use multi-layered panels with a water-retaining gel in the middle, called a hydrogel. When this gel gets hot, it releases its stored water vapor through an outer membrane. Other concepts involve intricate networks of tiny tubes running through the walls, mimicking the capillaries that bring fluid to our skin. The specific method might change, but the core principle remains the same. Use the incredible cooling power of evaporating water to passively manage a building's temperature. It's a beautiful fusion of biology, chemistry, and engineering. So where could we use this amazing technology? The possibilities are everywhere, especially in parts of the world that experience intense heat. Think about schools in hot, sunny regions. A sweating building could keep classrooms comfortable for students to learn, without the school having to pay enormous electricity bills for air conditioning. This would free up money for other important things like books and teachers. We could also apply this to public housing, making living conditions more comfortable and affordable for families who might not be able to afford to run an AC unit all summer long. This isn't just a luxury, it's about health and equity. Imagine large data centers, which are packed with powerful computers that generate a tremendous amount of heat. These facilities currently spend a fortune on massive cooling systems just to keep the servers from overheating. A building that sweats could handle a large part of that cooling load passively, drastically cutting down on operational costs and the environmental impact of our growing digital world. The same goes for warehouses, factories, and even office buildings in dense urban centers. By cooling the buildings themselves, we can also help reduce the urban heat island effect, where cities become much hotter than the surrounding countryside. The shift towards technologies like sweating buildings is absolutely critical for creating a greener, more sustainable planet. Our reliance on energy-hungry air conditioning is not sustainable in the long run, especially as global temperatures continue to rise and more people around the world begin to use AC. We need solutions that work with nature, not against it. By mimicking the elegant and efficient process of sweating, we can design buildings that are not only comfortable and cheap to run, but are also gentler on our environment. This is a powerful example of how looking to the natural world can help us solve some of our biggest challenges. Ultimately, the house that sweats is more than just a clever piece of engineering. It represents a change in our thinking, a move away from brute force energy consumption, and towards smart, nature-inspired design. It shows us that the best ideas are sometimes right in front of us, or in this case, on our own skin. As we continue to innovate and seek solutions for a changing climate, let's remember to look to the blueprints that nature has already provided. The future of architecture might just be a little bit cooler, and a whole lot smarter. Let's get to work.